Hey, and welcome to this lesson, which is all about spawning actors at runtime. At the end of this lesson, we will end up with our canon actor spawning our projectile actors repeatedly. So in the previous lesson, we imported some 3D models and we used these to create a blueprint actor for our canon. Now we want to take a look at how we can make our projectiles spawn from this actor. One of the first things we need to decide is where we would want our projectiles to spawn from. We want our projectiles to spawn at the end of the cannon's barrel. So how do we mark a spawn point of sorts inside this actor? Well, there's different ways we could do this. We could just use a scene component and move it to the end of the cannon's barrel, but I really want us to clearly understand the orientation of our spawn point. So let's add a arrow component. And let's name this projectile spawn point. And let's make sure that this arrow component is a child of the cannon. So the arrow component is just like a scene component really, but it has the benefits of rendering an arrow, so we have an idea of orientation. Also, arrow components are hidden in game by default. If you were to play the game, you wouldn't see it, and they also don't have any sort of collision that we have to worry about. So a quick challenge for you right now. I want you to adjust the arrow's location and orientation so it sits at the end of the cannon's barrel and also points in the same direction of the barrel. You can also adjust the size of the arrow and even its color in the details panel when you have it selected. So make sure to explore these settings. Okay, so pause here, and then when you have your arrow component set up, let's continue. Okay, so I'm going to select my arrow component, I'm going to rotate it and then translate it to the end of the cannon's barrel to about where I want the projectile to spawn. Now with the arrow selected, we can see on the details panel that we can adjust the arrow's size and we can also change the color to any color that we like the arrow to be. Now let's switch over to the event graph to begin coding the cannon's behavior. When the game starts, we want the cannon to wait for a short period of time, and then we want it to spawn our projectile actor class. And we also want to animate the cannon mesh to make it visually look like it's firing. And then we want this whole process to repeat. So to start, we're going to drag out from event begin play and we're going to call a delay. The duration of the delay is going to be the cannon's fire rate. If we put in 1 second for the duration, it's going to fire every second. Now we want to spawn our projectile class. So how do we do that? How do we dynamically spawn an actor at runtime in Blueprints? We haven't taken a look at this yet, but it's really easy to do. We can open up the Blueprint action menu and we can scroll down to the game section, and if we scroll all the way down on the game section, we can find spawn actor from class. So this node allows us to spawn actors dynamically at runtime. It may look a bit overwhelming at first if you've never used it, but it's really straightforward. We choose which actor class we want to spawn with this class drop-down selection here. We choose where we want the actor to spawn in the world with the spawn transform, and remember, you can split the transform pin to gain access to the location, rotation, and scale. And we also decide how the actor spawns if it detects its spawn point is colliding with something. And this is something to think about here because our projectile might be quite large when it spawns and it might be colliding with our cannon mesh. So we may need to make some adjustments. And then we have the return value, which simply returns the actor that gets spawned. So I have a challenge for you right now. Using the spawn actor from class node, spawn your projectile class. And for the spawn transform, use the world location and rotation of your projectile spawn point, and don't worry about the scale for now. And then loop the execution flow back to the delay. So pause here and have a good go at this challenge, and then when you're ready, come back to the lesson and we can continue on. So I have selected my projectile class using the class drop-down on the spawn actor node, and I have my projectile spawn point, the arrow component. I have its world location and its world rotation that I can use for the spawn transform. I'm going to right click on the spawn transform and split it to gain access to the location, rotation, and scale. We can plug the world location of our spawn point into this and the world rotation into the transform rotation there. Now with the scale, I'm going to leave this at 1, and the reason I'm doing this is because I don't want the scale of the arrow components to decide the scale of my projectile. And with the collision handling override, we're going to leave this on default, but I do know that my projectile is probably going to be too large to spawn, and the projectile will be colliding with our cannon. For now, I'm going to select the cannon mesh, and I'm going to remove the collision. I'm going to drop down the collision preset here and change its collision to no collision. And the final step here is just to make this code that we have here loop. We can drag out the output execution pin of our spawn actor node, and we can scroll all the way down to the bottom and we can grab the add a reroute node. So this is just a nice easy way of rewiring our blueprints here. We can drag this all the way to the delay, and we can double click on a wire at any point to create these reroute nodes. Okay, and that just allows our code just to look a bit neater for now. Okay, great. So let's check out the result of this. We can hit compile and save. We can come back to our level and we can hit simulate. We can use the hotkey for simulating, which is Alt S. So we can delay for a second, and then we can see that our projectiles are now spawning out of our cannon. So it's working, but we can see that the projectiles are still kind of large. But in the next lesson, we're going to take a look at exposing a property that allows us to adjust the scale of our projectiles and also the fire rate of the cannon itself. So when you're ready, I'll see you in the next lesson. Hey, and welcome to this lesson, which is all about exposing blueprint variables. By the end of this lesson, you will have learnt how to organize your variables better and also expose them directly to an actor's details panel when you select them in your level. Okay, so inside our cannon actor, we're spawning our projectiles every second at our projectile spawn point. We're going to take a look at a way we can easily control the scale of the projectiles that are fired from the cannon. We're going to start by creating a new variable, and we're going to name this projectile scale. And the variable type is going to be a float, not a vector. We can see on the spawn actor node that the spawn transform scale is a vector, but our projectile scale is a float. But look what happens if we click and drag it and connect it to the scale. It says it's not compatible with it because it's not a vector. But if we drag it onto the event graph and just hit get and connect this to the vector, it will convert the float to a vector. So what is this conversion really doing? Well, it takes whatever the float value is and it applies it to a vector uniformly, meaning if our float value was 0.75 as an example, the vector output value would be 0.75 for the x, y, and z values. And we can also see this explained when we hover over this node here. So I'm going to hit compile, I'm going to select my projectile scale, and I'm going to give it a default value of 0.6. Now we can close out of here and we can hit simulate, and we can see now that the projectile is a bit smaller than it was before. Okay, but what if I wanted to make the scale of the projectiles coming out of one cannon, like this cannon here, larger than the cannon next to it? How could we do that? Well, we could do this by exposing our projectile scale variable. Exposing variables is great for level design. When you expose a variable, it makes it visible on the details panel when you select an actor in a level. Adjusting exposed variables from the details panel only applies to the actor instance you have selected. And in the case of our cannon, it allows us to independently set different values for each cannon instance we've placed in our level. So how do we go about exposing a blueprint variable? Well, there's two ways that we can do this. We can look towards the My Blueprint tab, and where we have the variable, you'll notice this icon on the end of the variable name. So this is actually a closed eye, and we can click this to toggle it, and it opens the eye here. We can see the icon updates, and this means that the variable is now public, it's now exposed. And there's another way we can do it. We can simply select the variable, and we can see on the details panel we have this instance editable checkbox. Okay, and when we toggle this here, it also toggles the eye icon there as well. So they do the same thing there. So with it exposed, we want to compile our blueprint. Let's come back to our level and let's select a canon actor, and we can see on the details panel that we have our projectile scale exposed here. If we change this value, it only applies to this canon actor. This other canon actor here just next to it has the default value. Okay, so we can independently set these values for each canon if we want to. Okay, so it's a pretty powerful feature, and right now I want you to attempt exposing your own blueprint variable. The delay function that we've used in our canon actor represents the fire rate for the canon. So right now I want you to create and apply a variable for the canon's fire rate. And I also want you to expose this variable. So pause here, create and expose your variable, and then once you've done this, come back and resume the lesson. Okay, so we want to create and expose a variable for our cannon's fire rate. I'm just going to remove these two other events because we don't need these right now. And I'm going to zoom into my delay function, and with the duration parameter, I'm going to right click on this and promote it to a variable. And this is going to be the cannon fire rate. Now we can expose this variable by using the details panel, or we can just open the eye on the My Blueprint tab for it. Now let's hit compile, and if we come back to our level, we can see that if we select any of our cannons, we now see a cannon fire rate for it. We can independently change the fire rate for each cannon in our level. And by doing this, we can see that if we simulate, our cannons are now firing at different speeds. But if we select a cannon, we can see on the details panel that our variables are in a category named default, and we can type in any value into these variables. So if we wanted to put -5,000, we're allowed to do so. But what if we didn't want that to happen? What if we want to restrict how people use our blueprints? So let's think of this in the standpoint of working with a level designer. As the blueprint programmer, you may want to expose properties to level designers that they can use for the canon, but you might want to restrict them on which values they can use. And we can do this by coming back to our canon blueprint, and if we select a variable, we can see on the details panel that we have this category section here. It says here that editing this will place the variable into another category or create a new one. So we can simply select where it says default, and we can create a new category just by typing in a name. We can call this canon properties, and we can see when we do this, on the My Blueprint tab, we have a canon property section now. The projectile scale isn't in this yet, but we can click and drag it up and drop it into the section as well. Now to restrict values, we can select a variable, and on the details panel, we can see we have this slider range and value range here. So values will be clamped to this range. So if we put this value of 0.5 and 2 seconds, this would mean that our exposed fire rate will never be able to go outside of this range when we type values in on the details panel. And we could do the same with the slider, which allows us to clamp the slider range. And we want to make sure we do the same with the other variable we have here, which is the projectile scale. Now when we come back to our level, we can see that our variables now have a clamped range, and they are also organized in a category named Canon Fire Properties. So the result of all of this allows us to have much more control over our variables, but by exposing them, we open up lots of dynamic gameplay options where we can have different behaviors for each actor. Now we're nearly there with the cannon. In the next lesson, we're going to be finishing off the firing behavior by animating the cannon mesh to make it visually appear like it's firing. So when you're ready, I'll see you in the next lesson.